How do graphics cards work? Exploring GPU architecture. Have you ever marveled at the breathtaking visuals of your favorite video game? How are high-quality animations or lifelike lighting effects created on your screen? The answer lies with the unsung heroes of modern technology: graphics cards. In this video, we'll dive deep into how graphics cards, powered by their intricate GPU, graphics processing unit architecture, work their magic. Whether you're a gamer, a technology enthusiast, or someone simply curious to learn, this journey will leave you inspired by the innovation behind the visuals you see every day. Before we get into the details, let's start. What is a graphics card? A graphics card is a specialized piece of hardware designed to create the images, animations, and videos displayed on your screen. Whether rendering a beautiful virtual world in a video game or enabling smooth video playback, the graphics card is the behind-the-scenes mastermind handling these tasks. It works hand-in-hand with the graphics processing unit, GPU, the brain of the card, to perform all sorts of visual computations quickly and efficiently. Think about it like this. If your computer were a car, the GPU would be the turbo engine that ensures things don't just run, they run fast and look fantastic. Most of us associate GPUs with gaming, a key reason why they were developed in the first place. But did you know that GPUs have fundamentally transformed industries outside of gaming? They power artificial intelligence, cryptocurrency mining, and even scientific research. GPUs are the ultimate multitaskers, from training self-driving cars to simulating weather patterns. What makes them so powerful is their ability to handle massive amounts of data all at once. Unlike CPUs, which work sequentially on one task at a time, GPUs excel at parallel processing. This means they can perform thousands, even millions of calculations simultaneously, a crucial capability for rendering lifelike 3D graphics or analyzing large datasets in AI. At its heart, the GPU exists to solve one problem: speed and efficiency in rendering visuals. Creating the complex graphics you see in games, movies, or applications involves tremendous mathematical processing, from mapping light reflections to transforming 3D models into 2D images on a screen. Without the GPU's specialized architecture, this would take forever on a regular CPU. In simple terms, while your CPU is like an expert solving one problem at a time, the GPU is like a team of experts tackling hundreds of issues together. This is what makes GPUs perfect for rendering visuals in real time, whether it's while gaming or editing videos. Now that we know why GPUs are so revolutionary, let's break them down and understand their key components. The GPU contains hundreds or thousands of processing cores, usually called CUDA cores, for NVIDIA GPUs, or stream processors for AMD GPUs. These cores are the GPU's workforce, executing tasks simultaneously. For instance, when rendering a 3D scene, one core might calculate lighting while another processes texture details. This parallelism is the secret source of a GPU's immense power. Every GPU comes equipped with its own memory, called VRM. Please consider this a workspace where the GPU temporarily stores textures, frames, and images it's working on. VRM ensures the GPU can access data immediately, making rendering faster and more efficient. GPUs generate a lot of heat due to their computational intensity. Cooling systems, like fans and even liquid cooling, are built into the graphics card to keep them running smoothly. Without proper cooling, the GPU would overheat and throttle performance. The graphics pipeline is a series of steps that transform raw data into stunning visuals. This includes vertex processing, determining the position of objects in 3D space; rasterization, converting 3D objects into 2D pixels. Shading, adding colors, textures, and lighting to those pixels. The process repeats countless times per second to create the seamless motion we see on our screens. To truly understand the GPU's brilliance, let's visualize what happens when you fire up your favorite video game. As you move your character, the graphics card is hard at work, calculating every aspect of the scene, how the light interacts with objects, how water ripples, and how shadows fall across surfaces. This happens rapidly, frame by frame, to ensure the game runs smoothly and looks beautiful. While gaming remains a significant focus for GPUs, their potential goes far beyond entertainment. Here are just a few ways GPUs are pushing boundaries. Artificial intelligence, GPUs power AI models by processing massive datasets quickly. This helps in tasks like natural language processing, image recognition, and even training self-driving cars. Cryptocurrency mining. Mining cryptocurrencies involves solving complex mathematical problems, something GPUs excel at due to their parallel processing abilities. Scientific research. From simulating the cosmos to modeling protein structures in medicine, GPUs are indispensable in accelerating computations for groundbreaking discoveries. To understand it better, let's compare the GPU's power to the CPU. While the CPU is optimized for sequential processing, like running an operating system or performing calculations one after the other, the GPU is built for parallelism. The ability to divide and conquer tasks makes the GPU so much faster for rendering or data analysis. Consider how GPUs have impacted your daily life, even if you don't realize it. For example, when you stream a high-quality video, edit photos, or design 3D models, a GPU is often the hardware, making these tasks feel effortless. It's not just about speed, it's about making the impossible possible. Factors like core count, clock speed, and VRM determine performance when choosing a GPU. Core count dictates how many tasks the GPU can handle simultaneously, while clock speed measures how fast it can perform calculations. Benchmarking tools can also give you an idea of how well a GPU runs in real-world applications. If there's one lesson we can take away from the story of GPUs, innovation thrives when we solve problems creatively. GPUs were initially created for rendering better visuals in video games, but their ability to handle parallel processing opened doors to entirely new fields: AI, blockchain, and even scientific breakthroughs. This teaches us an important idea. Sometimes, the solutions we create for one problem have the potential to revolutionize the world in ways we never imagined. The future of GPUs holds incredible promise. Upcoming advancements include more energy-efficient designs, higher processing power, and integration into cloud computing services. These developments will continue to transform industries and expand the possible boundaries. The next time you launch a game, create digital art, or watch a crisp 4K video, take a moment to appreciate the cutting-edge technology working behind the scenes. GPUs are not just tools, but creations of extraordinary engineering designed to turn imagination into reality. So, let's continue to explore, learn, and marvel at the innovations shaping the world of technology. Who knows? Understanding the GPU could spark your curiosity for the next significant technological breakthrough. Thank you for watching. Let us know in the comments how GPUs have impacted your experiences or what topics you'd love us to explore next. Don't forget to subscribe, like, and share to spread the inspiration and knowledge. See you in the following video.